Hi, everyone. Welcome back. We're going to get started here with session 6, methods for analyzing linked data. My name is David Van Riper. I'm the Director of Spatial Analysis here at IPUMS, and I'm going to be chairing the session. So we have 3 talks in this session, and I'm going to introduce them all now, and then we'll go ahead and get started. So our first talk is Examining Historical Migration Through Linked Census Data and Geospatial Methods by Rock Miller. Rock's a graduate of the Hunter College Geoinformatics program, following a career in technology and capital planning in the public and private sectors. He's now an independent researcher at Paraploy Research in historical geographic information systems. Today's work is part of a multi-year project to develop graph-based spatiotemporal models and systems for analyzing historical processes and supporting historical inquiry. Our second talk is by Elizabeth Blake. She'll be talking about unlocking the past, methods to create a spatial data set of health and retirement study participants, 1940 enumeration districts. Elizabeth has been at the University of Washington for the past 3 years and just finished her first year in the PhD program in the Department of Environmental and Occupational Health. The majority of her work focuses on environmental epidemiology, specifically examining how environmental exposure, such as wildfire disasters, impacts the health and well-being of vulnerable populations. Our final talk is by Karin Ulery. The title is Disability as a Spatial Determinant of Internal Migration, a geoinformatics analysis using linked full-count U.S. censuses from 1850 to 1950. Karin holds a master's in public affairs from the University of Iowa and is transitioning into an MS in geoinformatics. She brings a long-standing interest in disability research, with current work examining how disability shapes historical migration patterns and the effects this has on policy outcomes. So I'm excited for these talks, and Rock, go ahead and kick us off.
Good morning. I'm Rock Miller, as we said, and I want to share with you some of the first step of a multi-year research project on migration and kinship. So the purpose of this research is to explore historical migration kind of through the lens of multi-generational kinship. And I'm relying on the full count linked census data to do this. So in today's talk, I'm going to introduce the framework by which these things are connected. And then I'm going to describe how the kinships are constructed from the full count linked census data. And then I'm going to walk through an example of how this could be used from a spatial standpoint in this case. The technical framework is based around building durable structures that represent kinships over multiple generations. I'm looking at this point at the period between 1850 and 1920. And essentially, once I've done that, the census records become a history of these kinships. And in particular, the place, the location at any one census period, enumeration, and also the household status in this case, which will be urban or rural. There are several parts to the system that's created to do this. The most important is the search network, which is built to find linked persons. It's a network of linked persons, and it's intended to find linked persons who are family relatives of a group of people at a particular time and in a particular location. So it's a recursive process where if you have linked people who exist in different places in different households year by year, you can find the other linked people in those places and then search for their relatives. So you'll end up with a study population that consists of not only the people, the starting people, but their whole kinship extending throughout the period. Say something about how you construct the families and kinships from the linked census data. There are 2 pieces to this. One involves the parents, where we're, essentially pivoting them across years. And it creates a kind of spine structure through time that allows us to relate linked and unlinked census observations, and also to essentially to look at marriages. If you look along the spine, in many cases you have remarriages. You also have widowhoods with children. And since we're looking for birth relationships, widows and widowers, there's a rule process to determine which distinct marriage the children belong to. The second part is to relate the child observations to the marriages that we've discovered in the first part. And as you can see, it's a graph process, the purpose of which is to define a birth order structure, and then to relate the observations to that structure. And if you have a case, as is seen in the colors, where two different observations seem to fall into the same birth order slot, you can infer that they're really the same person. These are kinship graphs. We use these graphs to model how the families are related to each other. In this case, the people, green for male, red for female, are the nodes in the graph, and they are related by lineage, which is green and red, and also by marriage, which is blue. So I'm gonna, gotta get the right end. Okay, so what you see here is actually a 4-generation kinship. I'm gonna focus on this marriage as the center. This is 1862 for the father, the birth date, and 1871 for the mother. And as you can see, we have records of the father's parents and siblings. And then we also have records of the mother's siblings and parents, and also a set of grandparents. Now, we can also see that the mother is actually the child of a second marriage. Her father has 2 marriages here. So what you're able to discern here is not only parents and grandparents, but also half-siblings, siblings, and aunts and uncles. And if these aunts and uncles had detectable children, you also have cousins, and they are all interrelated. Okay, so I'm going to shift over to how you can use this. In this case, I'm taking a study population that consists of people or families who were enumerated in 1870 in the bluegrass counties of Kentucky. There are 15 of them. And you see a lot of people outside here. This is a pattern that reflects historic settlement and maps very well to what historians know about how these areas were settled in the first place by Kentuckians. You have some concentrations in Louisville and Cincinnati. You're already seeing some people where kin can be both rural and urban. And you can also see the effects of the settlement of the lower tier of these Midwestern states, and also in the Missouri River Valley. And these are, so it reflects generations before. I want to say something about how we find these concentrations. I use a graph method called the Layden algorithm, which essentially tries to find nodes that are close to each other in relation to the weights on the edges. So in this case, the weights are partially adjacency and partially the size of the 2 nodes, the family presence. And so it builds a kind of armature of significant concentrations of people at particular places. Each place is a county. And then that makes it possible to pull out of this sort of large field of points where families are actually more prevalent. So we'll see how we can analyze this over time. This represents rural families or people who move to rural destinations. Pretty much everybody in the study population starts out in 1870 as rural. So in 1880, you can see already that there has been migration that has expanded a frontier district where the Missouri River Valley settlement, as you could say, of this study population has expanded into Kansas and also into North Texas. A lot of Southerners going to Texas. It's a big place. There's room for a lot of Southerners there. And this continues through 1900. It gets bigger. You have more people going into Southwest Missouri, which was not as populated then as it is now. This is the point mostly of dense settlement, and a little bit into Oklahoma because it had been opened for settlement a few years before. You also see more people and more coherent places in North Texas. And what's notable about this to me is that this whole area breaks up and gets smaller by 1910. So something happened very quickly in just a decade where you have a case where people seem to be going somewhere else. And since these are rural families, you have to ask yourself, where is that? This is also, in terms of time, the second generation. So I think you're looking at a picture, or could ask yourself if you're looking at a picture of people in the second generation deciding to move somewhere else. So we'll see about that. Urbanization was a major movement or trend all over the United States. This is a national representation of where the most important urban areas that the kinships of the study population can be found. These circles represent kind of the core places. Many of them were significant in 1870, and as you can see by the blue, they are pretty stable. You've got people coming in, and those settlements grow. But there are also a lot of other places. You have a pretty significant settlement in Los Angeles, and you have a lot of other places which have been expanded in the 1910, 1920 area specifically. So if we want to, I'll first use some terminology. We're shifting from a family focus to a kinship focus. And so I'm using kin presence basically as the number and weight of the kinships that are present in a place. I'm using significance to express the relative importance of that place among all other places in what you'd call the urban network. And that score changes over time. And I'm also dividing the kinships that are, and the people that are in those places by two categories. One category is what I'm calling settlement, which is the presence that results from, established kinships. So those are growing either because new kinship or new people from the same kinship move into that place, or because the children grow up and start their own families. And I contrast this with arrivals, which represent completely new kinships arriving in a place, in a given place. So this gives you an idea of the dynamics of this. You have, in 1900, relatively small number of urban places. You can see the dominant ones here, they're in red. We've seen these before. And they don't have a very high percentage of settled kinships because it's early in time. We're starting out here. And as time goes on, you get a greater and greater share that are settled, and that just simply represents the growth of those settled kinships. But in addition, once you start getting into 1910, you have people propping up in a lot of different places. And I focus especially on the bottom, which are places that are growing quickly. And, you can see that with Los Angeles and various places. The green and the blue represent smaller communities that are just coming out. And I'll add that in 1920, you not only have a lot more, but they change places. You have some places that grow, but you also have completely new places that have just appeared in this 10-year period. So I think we can look at some groups of these that represent some of the trends here. First panel is the dominant centers, which remain dominant, but they change places. Some of them grow faster than others in terms of significance. They move up the ladder, and others decline in terms of going down the ladder. In the West, it's clear that Los Angeles is a big source of attraction for this study population, much more than any other part of the West Coast. In the third, you can see, especially in 1910, 1920, that you're going into really rapid settlement and increase in importance in some completely new areas. Detroit which was, all of these places are growing and grew spectacularly in this period. So, and these are modern places. You have Detroit, which is making automobiles new. You have Akron, which builds tires for those automobiles. And Dayton is kind of interesting. It's close to Cincinnati, so it would be a place where you would go if there were jobs. I'll just mention that this is not a very important place now, but the airplane was invented in Dayton in this period. And also, they had a large group of calculating, tabulating machine companies, one of whom was founded by a guy who changed the name of it to IBM. So you're seeing tech emerging here too. And going back to what we saw before, you're also seeing that those cities that were in that southwestern area that was a very attractive place in 1880 are sliding down the ladder, except for Tulsa, which is in the middle of an oil boom. So I want to get some implications. I am hopeful that adding these kinship and geography structure will assist the linking process in terms of changing the probabilities of where you might find people to match. I think with kinship relationships, you have various different ways of filling the gaps. And when you have migration patterns, it not only is a county-to-county issue, but you can drill down to the kinship level and, therefore possibly dramatically reduce the probabilities other places and increase the probabilities in certain places of finding unlinked family members. And finally, I would talk a bit about marriage customs. I think that in general, if you see a couple migrating, most likely they have been married in the origin place, and that's where you'll find the bride's family, because that's how it worked then. If, on the other hand, you have a migration of a single person, usually a man, they're most likely to marry in the destination, and their spouse's relatives are going to be found there or nearby. So thank you. I'm looking forward to questions when we have questions. Thanks a lot.
Okay, hi everybody. My name is Elizabeth Blake. I am at the University of Washington, and off the bat, I wanted to take a moment and acknowledge the many co-authors that we have on this paper. That is because I wanted to make sure that all of my undergrads who were vital to this process had recognition. Unfortunately, I don't have everyone's picture, so I just wanted to take a moment right now, and they're also all on LinkedIn and can be found online if you want to reach out to them. So today I'm going to be talking about the project that I believe actually got me hired with Dr. Joan Casey at the University of Washington, which is creating a spatial data set for HRS participants at the enumeration district level. So starting off, everybody, the whole conference set this up nicely. I'm not going to spend too much time talking about it. I think everybody knows that there is an aging population in the US. The population pyramid is pretty dramatic. And this is of increased concern because there's projected double the amount of dementia cases looking forward into 2060, which poses a huge public health burden and also just quality of life issue. And so what we think about a lot from the environmental health side of it is exposures across the life course and environmental exposures and how throughout the life course they interact with one another, and thinking about where we can prevent or find ways to limit the incident cases, as there's no cure necessarily for ADRDs right now. And so a lot of studies, as we have seen throughout the past 2 days, are starting to try to disentangle what is happening. A lot of them use self-reported measures or are using spatial levels such as state or county level. And while those are really steps in the right direction, self-reported measures are often subject to recall bias, and state levels miss some of the neighborhood aspects, especially looking in earlier years, 1940, where segregation, well, still, was very prevalent. So that being said, we were looking for a way to increase or have a finer spatial resolution on residents and being able to pinpoint where they lived so that we could better do exposure assessments. Longitudinal cohort studies have been increasing in number, and they are a very powerful tool to be able to look at health outcomes over the life course. Everybody knows this guy, so I'm not going to spend too much time talking about it, but HRS, and specifically the work done here to link HRS to the 1940s census, provides a huge opportunity for looking at childhood exposures, especially on a spatial level. And the smallest, due to privacy concerns, smallest or finest scale we have is enumeration district level. And so we are using enumeration district as a proxy for a residential location. An enumeration district is basically analogous to a census tract. It is a purely administrative unit, I would like to point out, but they were used for the census up until 1970 and varied wildly in size based on population density. So in urban centers, they could span maybe 2 city blocks, whereas in rural Idaho, it was an entire quarter of a county. And so while the HRS linkage to the census provided us with individual level enumeration district codes for participants, these codes were not necessarily georeferenced to be able to use them for spatial data. And so to our knowledge, and at that point, there were no comprehensive 1940s ED spatial data sets. And like any sane academic decides to do, we decided just to do it ourselves. So we set out to create this data set. And I am going to spend kind of the rest or most of the talk, I would say, talking about the challenges and the process of working with physical historical data and bringing that onto a digital platform and what that entailed. First, I'm going to start and acknowledge the existing data set because it is a massive project. Dr. John Logan and his team at Brown University have created their Urban Transition Project, which has digitized over 70 cities across the US in 1930 and 40 on the enumeration district and ward level. But as their project focuses on the urban transition, there is a lack of rural data, which is important when you consider that in 1940, nearly half of the US population still lived in rural areas. And then when we're thinking about exposure and outcome differential between populations, 77% of Black Americans resided in the South, and 63% of those in the South resided in rural areas. So while this is a great starting off point to look at the urban transition, we wanted to sort of round out this data by adding rural areas, especially like the southeastern United States. And so next we were like, okay, cool, how are we gonna do this? And we turned to our nation's record keepers, and we went and looked at the National Archives and Records Association online archive, which I will be referring to as NARA. You can see here that there are a plethora of enumeration district and related maps available online, publicly available for researchers, but the little triangle of death, they are not all they're not all digitized and online. And as we go farther back in time, there is less coverage and availability for these maps. But most importantly, the 1940s maps, specifically 1940 and earlier, were all digitized in black and white. And it's not just me being lazy. It is really critical that they were in black and white instead of color, because you can see here that enumeration district lines are actually in orange. Ward lines are also included on the map. There's a lot of color going on. It's pretty fun, but that's practically impossible to disentangle when you're looking at a black and white map. So we needed to figure out how to acquire color scans of all of our maps for HRS participant enumeration districts. And so we reached out to the archival staff at NARA 2. I was going to College Park in Prince George's County frequently, not downtown, but the archival staff, just by nature, does not scan large quantities of maps for people off-site. That is not their job. That makes sense. And so over the course of a lot of time, multiple team members, including myself, went to the National Archives in CP and scanned these maps, which was great because I got a free flight home. And so now sort of talking about actually being at the archives and what that process looked like, I thought it was pretty unique as somebody who mostly works behind a computer with just numbers and data to actually kind of be in the weeds of it all. The general procedure of the cartographic room specifically at NARA is you submit these poll slips with the request for your specific records using identifiers such as county, and it includes information that can link you back to the researcher. Archival staff are the one who go back and pull those records for you. You're not allowed to go back there. The researcher themselves sorts through and pulls out what they would like copied or scanned, or sometimes people were just taking pictures of it, but in our case, we needed high quality scans. The archival staff completed those scans for us in the back with their oversized scanner, put them on a flash drive. I'm embarrassed to admit the amount of flash drives I had to buy because I kept forgetting mine. And then the maps are returned, you put them back where they're supposed to be, and you return them to, the archival staff returns them back to the back record rooms. And this was not as straightforward as it seems. At almost every point, there was something that sort of slowed the process, even if it did make sense or was administratively reasonable. But for poll slips, you had to limit yourself to 2 counties or 2 identifiers, and you could only submit 5 poll slips at a time. Then you were also limited to 1 cart, and that cart could only have 10 of these sort of, you can see massive folders on them. And if you go over your allotted cart, you have to resubmit and go through the process again. This sort of goes back to the density thing I was talking about, where maps vary wildly in size and the amount of maps in a county vary wildly. So some of these folders have literally 2 maps in them of the entire county. Some of them have over 100 maps in them, so sorting through them. Also 40s and 50 records were kept in the same map, so making sure that we're pulling the right ones. And then you were limited to 10 scans per a set, and scans cost $350, which adds up, I'll just say that. So then with the maps themselves, sometimes they were too old to actually scan and we had to take overhead pictures, reducing their quality, or they couldn't be scanned, and sometimes rescans had to be happen, so it was kind of a back and forth process from time to time. And one of the major things, which is good in general, is that the archival staff did not just give you first come, first served basis. If there were people there who had not had records pulled or copied that day, they got to go in front of you, to be fair. But as someone who was cranking through it, it was frustrating from time to time. And now I'm gonna talk a little bit about, once we actually had these maps, what the process looked like and what we did. We used ArcGIS Pro, and it was a combination of georeferencing and digitizing these maps. I'm going to flip through sort of quickly ArcGIS Pro interface for those who are not familiar, but basically georeferencing is taking a paper map or a scanned map and giving it spatial information. And so to do this, we need to basically map it up with a map that does have spatial information. Back in the day, this was done literally using pins and sort of pulling. So that's where the idea of control points come from, where you're grounding your scanned map to the map that you're referencing to in the background, in our case, the ArcGIS base map. And you can see here that the variety of points and the location of points of where you want to georeference is very specific based on the map or based on the enumeration districts you needed. So this was a manual process, and this is where the undergrads were critical. Then after we have georeferenced and we're confident that this is where the map actually belongs, we created a feature class, and this is where we actually created the enumeration district points. We created geographic centroids, as we didn't have population, so they couldn't be population weighted, of enumeration districts within the HRS data set. And I will say off the bat, these are not HRS participants. This is actually the places I lived when I lived in Ann Arbor. And we added our attribute information, which included a county state code, the ICPSR code, the enumeration district number, and then we generated lat-long coordinates so that people could have this as a flat file and turn it into spatial data themselves instead of a massive spatial data set. We took on that burden instead. And so our results, we finally finished about maybe 3 months ago. In total, we scanned over 1,700 maps, and we covered 9,424 HRS participants, and the data set has 6,836 points in it. That is across 47 states and 94 counties. The 3 states missing are Alaska, Hawaii, and Nevada. That's controversial, I think. We can see here, unsurprisingly, a majority of the HRS population that we digitized for resided in the southeastern United States, in the Midwest, which makes sense given historical trends of the Great Migration and such. This map is on this sort of larger scale due to privacy concerns. I didn't even know these census boundaries existed. And so then finally, I kind of wanted to talk a little bit about the application or what our group is planning on using this data for. This is an example of the roadiness metric that colleagues at GMU created, where it is a measure of a road infrastructure using historical street grids to produce how much someone was exposed to kind of like roads. And this is on a fine scale level, so it's a 1 kilometer data. As you can see, this is the city of Detroit. And these are, again, not HRS participants, but this would be an example of how on a finer scale, on an individual level, you can assign environmental exposures to participants. And so we have posted this, or it is available on HRS for all researchers to also, who have HRS enclave access, to be able to do this type of spatial research and to start asking new questions that previously had not been feasible to ask without this data. And that's it, actually. But thank you guys so much. And
good afternoon, or good morning still, everyone. My name is Karin, and I have a Master's of Public Affairs, and I will be beginning my Master's in Geoinformatics at the University of Iowa this fall. Today, I'm presenting Disability as a Spatial Determinant of Internal Migration, 1850 to 1900. Sorry about the change in title. We shrunk back a little bit just because of the amazing amounts of data. This is a perspective methodology presentation. I'm not showing final results, but rather the infrastructure and conceptual framing and analytical approach that will make this research possible. This project is built directly on IPUMS USA and MLP full count microdata, along with state, county, and local administrative records, and it aims to create reproducible infrastructure for linking disability information across census, institutions, and archival sources. My ultimate goal is to show how disability can shape mobility, opportunity, and constraint, and how institutional geography played a part in structuring those patterns. The motivation is straightforward. Disability and migration are deeply intertwined, yet historically understudied. We need infrastructure that allows us to link disability and data across censuses, connect individuals to institutions, model spatial determinants of movement, and ultimately understand how disability shaped life trajectories. This project helps to build that foundation for this work. The problem is that historical disability records are fragmented, inconsistent, and systematically underlinked. Disabled individuals are disproportionately found in institutions, group quarters, and non-family settings, and those populations have unstable identifiers, inconsistent naming, and sparse contextual information. Standard linking methods systematically exclude them, to study disability as a spatial determinant of migration, I need a linkage method that can handle missing family structures, inconsistent institutional naming, disability-related free text fields, high ambiguity in census records, and this is the motivation for a new methodological approach. To build my methodology, I plan to start with a basic linkage framework like ABEI. ABEI is a rule-based algorithm, just like ABE Basic, that came before it. This improves historical census linkage by adding extra identifying information, things like middle names, parents' names, spouses' names, and counties of residence. These additions increase match rates and accuracy for most of the population. However, ABEI has a critical limitation for the groups I study, becomes systematically less representative for people living in group quarters, places like almshouses, schools for the blind and deaf, hospitals, and asylums. And historically, this is exactly where most disabled people were living in the late 1800s. The reason is structural. Group quarter residents rarely have the extra information that ABEI relies on. They don't appear with spouses or parents. They often lack middle initials, and their county of residence reflects the institution rather than their home counties. As a result, ABEI can't break ties between individuals with common names, and those records are disproportionately discarded. So for disability research, ABEI gives us a foundational linkage framework, but it also exposes a major methodological gap. My work addresses this gap by bringing in a second approach that can handle exactly this kind of records that we struggle with. One example of this is one example of handling this limitation is a framework created by Ather's LLM-assisted record linkage framework. This approach is designed specifically for the kinds of records that rule-based algorithms struggle with: messy, sparse, and highly ambiguous cases, which is exactly what we see for disabled individuals living in institutions. Ather's methods keep the strength of traditional probabilistic linkage, in this case starting with probabilistic matches, but instead of discarding ambiguous cases, it routes only those uncertain pairs to a large language model. The LLM can interpret free text fields, things like institutional names, disability descriptors, or occupational labels, such as inmate, patient, or pupil, that the ABEI cannot use at all, and that traditional string matching methods cannot adjust for it. The key innovation is that the LLM's decision isn't taken at face value. It can be combined with the original match probability through a Bayesian updating, and this means that the LLM acts as an additional piece of evidence, strengthening the match only where it aligns with other signals and preventing errors when the model is uncertain. The result with this hybrid system is that it reduces the number of ambiguous cases by more than half in the case of Ather's model, increases match certainty for institutional residents, and preserves transparency and reproducibility, all of which are essential for historical census research. This type of framework directly fills the gap left by ABEI and provides a methodological foundation for my own linkage approach to studying disability and migration. On the previous slide, I showed how Ather's framework is one way to use large language models to resolve ambiguous record pairs, but I can't simply use regular LLMs for 19th century census data. It's trained on contemporary language, not historical disability terminology or institutional vocabulary. This creates a strong modern language bias that would distort the linkage process. This is where historically trained models become essential. Time capsule LLM is one example of this. It's built entirely from Victorian-era books, newspapers, and legal documents. Its language understanding is grounded in the period itself. My plan is to take this idea further. I will use administrative records from historical institutions, almshouses, schools for the deaf, blind, hospitals, and asylums to fine-tune a model like time capsule LLM. That way, the LLM will understand the exact disability labels, institutional names, and record-keeping practices that appear in the late 1800s. Once trained, it is hoped that I can use this historically aligned LLM in the same Bayesian framework Ather proposes, giving me a tool that can interpret the messy free text institutional records that we cannot currently handle. This project has 3 central questions. How did institutional geography shape migration patterns for disabled individuals? What can longitudinal histories tell us about the role of culture, support networks, institutions, and policy in shaping mobility? And to what extent were migration decisions strategic, a coordination game, rather than simply responses to institutional availability? These questions require data that is both spatially explicit and historically deep. The core data set is IPUMS USA plus MLP full count microdata from 1850 to 1900. This includes harmonized disability variables and migration indicators, which I hope to improve with my LLM models. I also use geocoded lists of currently more than 300 institutions, including currently schools for the deaf, asylums, and poorhouses, while I am continuing to add more institutional data by the day, which it currently includes opening year, type, and operational status. I've created the existing institutional list by searching the web primarily with hathitrust.org for state and federal institutions, then compiling and sorting them with Python. I'm currently working on data scraping code to help streamline the process of collecting open source digital versions of these institutional records. Finally, I plan to incorporate archival text from HathiTrust, Ancestry, and state archives and institutional histories, much of which is available currently on the web. This combination allows us to connect individuals, institutions, and places across time. Currently, here are the disability counts that I've processed so far. We have over 20 million records from 1850 total, with more than 22,000 blind and deaf. And currently, I'm using blind and deaf because they are the most stable variables across time. So that's what I'm beginning. Hopefully, as I progress in the project, we will begin to add forgive the terms, but maimed at the time, which includes a lot of veterans, which will affect VAs and soldiers' homes. But for now, I am currently sticking with blind and deaf as the most consistent variables across time. So 22,000 blind or deaf as of 1850, 1860, over 27 million records with 23 million blind or deaf, 1870, over 38 million records with an increase of 40,000 blind or deaf. I have not currently included 1880 or 1900, and that is intentional for 2 reasons. The first is technical. 1880 and 1900 full count files are extremely large, and computing them, I currently don't have the computing power available. I will be processing these later in the next few months using chunked workflows in cloud-based environments. And the other factor is historical. The census removed disability indicators in 1880 and 1900. This reflected the rise of institution enumerators recorded the institution, but not the disability. This creates a major blind spot. We know where people live, but not why they were there. This is another reason why institutional record extraction becomes essential. The institutional data set I've created so far, again, includes over 300 geographical geocoded sites. Each record has temporal attributes and allows me to build time-layered maps. These layers will be integrated with disability prevalence from the IPUMS USA to visualize institutional density and accessibility over time. Migration decisions are can be modeled as, wrong one, sorry. Okay, now yesterday a question was asked about if we had unlimited sources and unlimited finances, and where can I imagine that this data set that I'm trying to create goes? One of my passions is game theory, and There we go. One of my passions is game theory, and I love the idea that it is possible that migration decisions can be modeled as a coordination game. Individuals and families anticipate the actions of institutions, communities, and policymakers, and they weigh uncertain payoffs such as access to care, stigma, cost, distance, and available support networks. This framing helps formalize how disability-related migration is shaped by bounded rationality, limited information, and structural constraints. The decision tree on this slide illustrates that logic. Each node represents a choice, each branch a possible outcome, and each institutional access, social support, and environmental barriers. This tree captures how actors anticipate others' responses and select strategic and maximize expected utility under uncertainty. It also reflects the constraints emphasized in the disability and migration literature: fragmented institutions, inconsistent eligibility rules, and uneven services landscapes. By treating migration as a coordinated response to environmental and institutional conditions, the framework helps explain why some disabled individuals or families move while others stay where they are. The coordination game model provides a structured way to interpret historical migration patterns and to connect individual choices to the broader geography of disability and institutional infrastructure. Thank you.